Hello all, welcome you all to the new lecture of the chapter Motion in a Straight Line. And in the previous lecture, we have discussed many mathematical concepts, right? Now you know how to differentiate, how to integrate, how to find equation of a line, and you know many things, right? We have learned about motion. We have discussed about what is meant by uniform motion, what is non-uniform motion, what is non-uniform motion with uniform acceleration, what is non-uniform motion with a varying acceleration, etc. We have discussed many things, alright? So I am going to brief that first of all. Okay. So the motion are basically of two types. The first one is uniform motion, okay, uniform motion, and the next one is non-uniform motion, okay, non-uniform motion, non-uniform motion. And in uniform motion, what is meant by uniform motion? The velocity is constant, right? The velocity is constant. Velocity is constant. Okay, constant. Which means your acceleration is zero. Clear? Velocity is constant, which means your acceleration is zero. For solving such question, you have only two equations, two possible equations. Which are that two possible equations? One is speed is equal to distance by time, or the next one is velocity is equal to displacement by time. These are the two possible equations in order to deal with the uniform motion. That is the case where velocity remains constant. Okay, and here you know the velocity will be vary, right? The velocity is varying. Okay, it changes with respect to time. And here the acceleration will not be zero, right? Here the acceleration will not be zero, which means there is acceleration. Okay. Non-uniform motion can again be classified into two. That is non-uniform motion with uniform acceleration. Okay. Non-uniform motion with uniform acceleration. Uniform acceleration. Okay. What is meant by uniform acceleration? Your acceleration value is constant. Okay. Acceleration value is constant. Okay. Then you have non-uniform motion with a non-uniform acceleration. Non-uniform acceleration. Non-uniform acceleration. Which means your acceleration is varying. As the time changes, the acceleration changes. Okay. It means your acceleration is varying. Okay. And now in order to deal with the uniform acceleration, you are having kinematics equation, right? Kinematics equation. Which are the three equations you have learned? You have learned V is equal to U plus AT, 2AS is equal to V square minus U square, S is equal to UT plus half AT square. Alright? So you have to remember, for dealing with non-uniform motion with uniform acceleration, you can use kinematics equation. V is equal to U plus AT, 2AS is equal to V square minus U square, S is equal to UT plus half AT square. Also you can use calculus method. Okay. Also you can use calculus method. Okay. So calculus method is also applicable. You can use that. Now For dealing with non-uniform acceleration, okay, you have only calculus method. You have only calculus method. Okay, you have only calculus method. In a case where acceleration is varying, you can never use kinematics equation. You have to use calculus method. Here the acceleration is constant. Okay, in kinematics equation. So this is something you have to understand in order to do problems. Okay, you have to understand it thoroughly. You have to learn every equation. Okay, so you copy this to your notebook. Okay, then now let us move on to this particular method, that is calculus method. Okay, actually when we say about calculus method, you have already learned differentiation and integration. Okay, now I am just showing you using calculus method. I am going to show you the graph of different motion. Okay, graph of different motions, and we will again use all these equations, that is kinematics equation, calculus method, as well as this equation of uniform motion in the next lecture in order to solve many questions which are related to graph as well as some other questions too. Okay, that is questions related to instantaneous velocity, instantaneous acceleration, like that. Okay, so after watching all the lectures, you will be very clear with all these kinds of methods, how to use it. Okay, so let's move. Okay, and understand more and more about graph of different motion. Okay, graph of different motion. Now there is a very important note. You have to note this figure. Okay, suppose this is displacement. Okay, you mark a box. This is displacement. Then here is velocity. Here is velocity. Okay, velocity. And here is acceleration. Okay, now in order to move from displacement to velocity, okay, or the relation between displacement and velocity, that is, you have to find the slope of displacement in order to get the velocity. Okay, either you can say it is the rate of change of displacement is called velocity. Okay, or slope of displacement time graph is velocity. Okay, so there you have to find slope. What is actually slope? In mathematics, slope means differentiation. Do you remember that? So here you can say your velocity v is equal to dx by dt. Okay, where your x is the displacement, v is the velocity, a is the acceleration. Okay. So, slope of displacement time graph gives you velocity, or the rate of change of displacement is velocity. Both are same. Now, if you find the slope of velocity time graph, okay, if you find the slope of velocity time graph or rate of change of velocity, then that is called as acceleration. Okay. So you can say here also you have to find the slope, that is your acceleration A will be dv by dt. Okay, dv by dt. Clear? Now there is another way of telling this. You may have heard this. Okay, the first derivative of displacement. This is basically derivative, right? This is basically derivative, that is differentiation. and you are differentiating displacement once to get velocity. You are differentiating velocity once to get acceleration. Is that clear? Then what will be the relation? This one. That is from displacement to acceleration. Yes, you have to differentiate 2 times. You have to differentiate displacement in order to get acceleration. Right? If you differentiate displacement once, you will get velocity. If you differentiate velocity once, you get acceleration. Which means if you differentiate displacement 2 times, you get acceleration. Right? Yes. So you can say that acceleration is second order derivative of the displacement. Okay. You have to differentiate displacement twice to get acceleration. D square x by dt square. This is called as second order derivative. Second order derivative. Second order derivative means that differentiate twice. Third order derivative means differentiate 3 times. Fourth order derivative means differentiate 4 times. Okay. So here it is second order. So that is square here. Second order. Second order means you differentiate displacement 2 times to get acceleration. While you are differentiating, when you complete the first time, you will reach at velocity. When you again differentiate, you will reach at acceleration. Is that clear? So let's write that. First derivative of displacement, first derivative of displacement is velocity. Okay. Now, first derivative of velocity is acceleration. Okay, which means second derivative of displacement, second derivative of displacement is acceleration. Okay, so you have to understand these 3 points. It is very important. First derivative of displacement will give you velocity. First derivative of velocity will give you acceleration. Second derivative of displacement will give you acceleration. Okay, I hope these things are clear to you. Okay, now what is the reverse process of differentiation? What is the reverse process of differentiation? You remember that it was integration. And what is mean by integration? Integration means summation or you are finding the area. Either it is summation or you are finding area. Okay. So, from acceleration to velocity, you have to find the area under graph. So, how can you write the equation? Your velocity is integral of acceleration with respect to time. That is integral a dot dt. Okay, where the variation is in time. Clear? Now, from velocity to displacement also, you have to find the area. So, you can say your displacement x is nothing but x, or you can put s. Displacement x or s, whatever it may be. Okay, s is equal to integral v dot dt. Clear? Displacement s is equal to integral v dot dt. Clear? So that is the next point you have to remember. That is area of acceleration time graph. If you find the area of acceleration time graph, you will get velocity. If you find the area of velocity time graph, you will get displacement. I think you remember the derivation of this kinematics equation, right? S is equal to ut plus half a t square to as is equal to v square minus u square. There also I have told you the same point, that is, if you find the area of velocity time graph, you will get displacement. Okay, so this is how mathematically we represent them using calculus. Okay, so that is basically the calculus method. You have to understand these relations. That is called calculus method. Okay, and now you know how to differentiate and integrate. And we will work out more problems related to physics using this calculus. So you will understand that in a more clear way. Okay. So the next point you have to remember is area of acceleration time graph is velocity. Okay. Also you have to understand area of VT graph is, okay, area of VT graph is displacement. Okay, displacement. Okay, so I hope you have copied all these things. Okay, you have to note all these things. It is very important. Okay, very important. Okay, so I'll erase it. So now let's discuss the graph related to motion. Okay, so let's discuss about the graphs. First we will discuss the graph of a body at rest. So first we will discuss the graph of a body at rest. Okay, so let's draw the graph. Okay, you have to understand, if a body is at rest, which means your velocity remains zero, right? Your velocity remains zero, which means velocity is the first derivative of displacement, right? Velocity is the first derivative of displacement, and that is zero, right? Velocity is dx by dt will be zero. You know that derivative of a constant is zero. You have learned the formula. Derivative of a constant will be zero, which means that your displacement is constant. Okay. So whatever be the initial position, conceptually, this is mathematically. Okay. Now conceptually you think that if a body is at rest, then from the origin, from the frame of reference, the initial position of the body should not change. Position should not change with respect to time. Right? As time passes, the body's initial position from the origin should not change. Then the body is at rest. That was the definition for rest. Okay. So here the initial position should remain constant. So this is our origin. Graphically, this is the origin. Here we will mark displacement. Here is time. Okay. So suppose this is the initial position. From the origin, it is the initial displacement. Then that should remain a constant. Which means as time passes, your displacement should not change. The value, whatever be the value here, that should remain a constant. Okay, it is not varying with respect to time. Okay, that value remains as such. So this is the graph for a body at rest. You have to note these things. Okay, basics. It's very important to note these things. Mathematically, if you have your y is equal to, say, k, where k is constant. Okay, If you have y is equal to k, where k is constant, okay, then graph is parallel to x-axis. It's very important to note these things. Okay. Now the next thing is, if degree equal to 1. You know what is mean by degree of a polynomial, right? It is the highest power of the polynomial. It is the highest power of the polynomial. That is the highest power of the variable in that polynomial, right? That's called as degree. If your degree is equal to 1, then graph is a straight line. Your graph will be a straight line. Okay. Now, the third point is, if the degree of the polynomial is 2, if the degree of the polynomial is 2, then graph is a parabola, right? Parabola. You know what is a parabola? Something like a U-shaped graph, right? That is what is parabola. So these are the things that you have to remember. Okay, in order to understand the graph, you have to remember these things. Now listen, y. Your y-axis is displacement. This is y-axis. This is x-axis. So here y is displacement, that is x. And that was a constant, which is k. Then graph is parallel to x-axis, right? Graph is parallel to x-axis, that is time axis. Clear? So that is the conceptual as well as the mathematical idea behind the graph of body at rest. I think you are clear with this concept. Okay. Now, let's move to the next one. Okay, the next one is for body having uniform motion. Body having uniform motion. You have to remember there are basically 3 types of graph. That is displacement time graph, velocity time graph, as well as acceleration time graph. So for this body having uniform motion, you know that if the body is having uniform motion, then acceleration is 0 because your velocity is k, where k is constant, right? So since acceleration is 0, you don't have to think about acceleration time graph. Okay. Since the acceleration value is 0 for body having uniform motion, you don't want to think about acceleration time graph. Okay. Now, your velocity. Okay, what is meant by uniform motion? Uniform motion means your velocity remains a constant, that is velocity equal to k. So definitely you will have a velocity time graph. Similarly, you will have a displacement time graph. Okay. So first we will draw the velocity time graph. First we will draw the velocity time graph. Okay. Here is time, here is velocity. Okay. Since velocity remains constant, okay, that is your y equal to k, that graph will be parallel to x-axis. Graph will be parallel to x-axis. Alright? Alright? Velocity value should never change as the time passes. So if the initial velocity is here, that value will never change. It remains as such as the time passes. So whatever be the time, the graph will be like this, straight line parallel to x-axis. Okay, this is our origin. Clear? Okay. Now, so you have to understand both mathematically as well as conceptually. Okay, conceptually as well as mathematically. Now, coming here, okay, we need to find displacement. We know that the displacement is the area under the velocity time graph. You remember this formula. S is equal to integral v dot dt, right? So here your velocity is k, so it is k dt. You know how to integrate. You can take k outside. So k taken outside, it is integral dt. What is integral dt? What is integral dx? What was integral dx? Integral ds is x, right? So what is integral dt? It will be t. So that is kt plus c. Plus c. Why plus c? Because it is indefinite integration. So my concern is not about this equation. I am concerned about the power of the variable. Power of the variable. Here the variable is time. Here the variable is time. And what is the power of this time? The power of this time is 1. Okay, which means the graph is a straight line. The graph is a straight line. So let's draw the displacement time graph. Here is time, here is displacement, here the power is 1, degree is 1, okay, and the slope is k, okay, slope is k, so this will be like this, alright. So this is the displacement time graph for a body having uniform motion, okay. Now think of it conceptually, okay. Uniform motion means your velocity remains constant, and I have also discussed that is the change in displacement, okay, is equal in equal interval of time, right? Change in displacement is equal in equal interval of time. That is, the displacement vary as the time vary linearly, right? So how will be the graph? As time is 0, the displacement should be 0. As time increases, the displacement should increase, right? So, and I have also given you the example for that. That is, change in displacement is equal in equal interval of time, so that the velocity remains constant. We have discussed with an example. That is, I have drawn a time axis where we mark the position as well as time. Then we calculated, right? Yes. So conceptually also mathematically you can arrive at this graph. Okay. So I hope you understand this graph. Now we are going to discuss the graph of body having non-uniform motion with constant acceleration. Okay, non-uniform motion with constant acceleration. Whenever in a problem there is non-uniform motion, first of all you have to look whether that non-uniform motion is with a constant acceleration or varying acceleration, because non-uniform motion are of two types. So we are discussing non-uniform motion with uniform acceleration. This is what we are discussing. Okay. Body having non-uniform motion but with uniform acceleration, which means your acceleration remains k. That is, acceleration is a constant, where k is a constant. Acceleration remains constant. So definitely it is going to have an acceleration time graph. It is going to have an acceleration time graph. And now you can draw the graph yourself, right? Because acceleration is k, your y is k. Y remains constant. The graph will be parallel to x-axis. The graph will be parallel to x-axis. Alright? That is, here x-axis is time axis. So I hope you understand this graph. Okay. Now let's draw the velocity time graph. Okay. Since your acceleration is constant, how to draw velocity time graph? You know that velocity is basically area of acceleration time graph, right? Acceleration time graph area is called velocity. Okay. So it is integral. What is the acceleration here? The acceleration is k, that is constant. So instead of this a, put k dt. Now what can you do? You can take this k outside. You can take that k outside. Then remaining is integral dt, which means it is k t plus c. Kt plus c. Plus c is the constant of integration. Okay. So here also we are concerned about the power of the variable, that is degree of this polynomial. Degree of this polynomial. The degree of this polynomial is again, here the power of time will be 1. 1. Which means graph is a straight line. Graph is a straight line. Alright? Graph is a straight line. Okay, so now you understand the idea. Now you understand the idea. So graph is a straight line. Okay. Now let's copy this velocity equation here. The velocity equation we get is kt plus c. Okay, kt plus c. Kt plus c. That is the velocity. Now we need to draw the displacement time graph. This is acceleration time graph. This is velocity time graph. The next possible graph will be displacement time graph. So how to draw the displacement time graph? First of all, you copy all these things. Okay. Now I will erase it and I will draw here. Okay. I'll draw here. Okay. Now how to draw the displacement time graph? You know that the displacement is the area of velocity time graph. Am I right? Am I right? Displacement is the area of velocity time graph. What is your velocity equation? Velocity is kt plus c. Kt plus c. So let's substitute it here. Integral kt plus c dt. Now integrate separately. That is integral kt dt plus integral c dt. Now here you take k outside. It is integral t dt plus, here you can take c outside because k is also a constant, c is also a constant. So take c outside. You have integral dt. Now what about this? This is similar to integral x raised to n dx. That is, your answer was x raised to n plus 1 by n plus 1. Do you remember? Do you remember this formula? So that same thing is here. Integral t dot dt. So here the power is 1. I hope you have learned integration from the previous video. Okay. So it is something like k into n plus 1, right? So that is t square by 2 plus c into integral dt is t. Integral dt is t. And if you need, you can again put a c dash. That is constant of integration. Since it is indefinite integration. Indefinite integration. Okay. Now you think here. Well, I am concerned about the power of the variable. Okay, that is the degree of this polynomial equation. What is the degree? It is very clear that the degree is 2. That is the highest power available. Highest power available is 2. That is degree is 2. So the displacement equation, your degree is 2, which means the graph is a parabola. The graph is a parabola. Okay. The graph is a parabola. So graph is going to be a parabola. How to draw a parabola? You have learned in 10th standard how to draw a parabola. How to draw a parabola? This is time and here we mark displacement S. Okay, how to draw a parabola? We know how to draw parabola, right? We know how to draw parabola. This is a second degree equation. Graph will be a parabola, that is displacement time graph is a parabola. But the thing is, in physics, time can never be negative. Time can never be negative. So this part of the graph can be neglected. We don't have negative time axis. Can you say -1 second or -2 second or -3 second? No. Your time starts from 0 second only. Okay, so this will be your graph. This will be your graph. I hope it is clear to you. So there are three possible graphs for body having non-uniform motion with uniform acceleration. Okay. Okay. Yes. Now definitely we will practice more and more questions so that these all become easy for you. Okay. Now there are some graphs which are not possible. There are graphs which are not possible. So these are the basic graphs that you need to know. Okay. Now graphs which are not possible. Graphs that are not possible. What are the graphs that are not possible? Okay. So I will draw three graphs here. Okay. And you have to analyze yourself why these three graphs are not possible. You have to find out a reason. Okay. Then this is the first graph, that is VT graph. Now here is speed, here is time, and here is the graph. Now here is time, here is x or s, displacement. Okay, x or s, whatever it may be. Okay. Now tell me why these three graphs are not possible. Why these three graphs are not possible? There are three graphs. Why these three graphs are not possible? Find out. Okay. Just think yourself. Is this graph is possible? No. Why? Why? See, for a single time, I'll give you here. Suppose I choose a time t1. I choose a time t1. Then there are two possible velocity. One is here. This is velocity v1. And if you extend this graph, here also there is another velocity v2. In the same time, the body have two velocity. Is that possible? Is that something possible? No, it is not possible. Okay. So, you cannot have two value, two or any value. You should have only one value. Okay. So, more than one value, you have to write reason. Okay, write yourself. More than one value of velocity, displacement or acceleration is not possible at an instant of time. At an instant of time, you cannot have more than one value of velocity or acceleration or displacement, whatever it may be. So you have to write a general reason for this. Okay, why it is not possible. Now come here. Second one. Why this graph is not possible? This graph is not possible because speed is a scalar quantity. Speed is a scalar quantity. That cannot have negative value. Speed cannot be negative. But the graph is in the negative region, right? The graph is in the negative region. This is the origin. So the graph is in the negative region. Hence, this graph is also not possible. This is also not possible. Now, what about the third one? What about the third one? Why the third graph is not possible? It is because here you can see the time is fixed. The time t1 is fixed. And the displacement is increasing. The displacement is increasing. In physics, can you change displacement or acceleration or velocity Without varying time, you can't change, right? Always they should change with respect to time. Here time remains a constant and displacement is varying, which is not possible. The time should also vary. Okay, hence the third graph is also not possible. So I hope you understand why these three graphs are not possible. So there can be questions like that in your competitive examinations also. So you have to analyze properly why the graph is not possible. This could be the reason. Out of these three, any of will be the reason. Okay. Now I will teach you one more concept, and after that we will stop this lecture. Okay, the rest of the questions, rest of the concepts will be discussed in the next lecture. So you have to put a note. Now you have a graph of vector quantity. Graph of a vector quantity. They have given you the graph of a vector quantity. Whatever be the vector, it can be either displacement, it can be velocity, it can be acceleration, whatever it may be. Or when you go to work energy power, it can be force. Okay, it can be anything. In general, you have a vector quantity. So here it is that vector quantity. Here is something like time. Okay, think it is time. Okay, we are telling an example. Okay, suppose if the graph is something like this. Suppose if the graph is something like this. Okay, then you want to find another quantity which is the area of this graph. Suppose this area is A1, this area is A2, this area is A3. You know this will be a positive answer, this can be a negative answer, this will be again a positive answer. Above the x-axis will be positive, below the x-axis will be negative, right? Okay. So now you want to find another quantity, okay, another vector quantity, let's say V, okay, another vector quantity V, which is area of this graph, area of given graph. Okay, so you are given a graph, and you have to find another vector quantity, that is the area of this. The relation is, it is the area of this graph, something like displacement is the area of velocity time graph, like that. Okay, then your V will be just the sum of this, that is A1 plus A2 plus A3 plus etc. Okay, so you don't have to look at the sign. Okay, sorry, you have to look at the sign. A1 is positive, A2 is negative, A3 is again positive. Just you add them considering the sign. Okay, then you will get the required vector quantity. Now what will be the corresponding scalar quantity? Corresponding scalar quantity will be, you have to add the area without considering sign. That is V will be equal to, okay, or say magnitude of V will be equal to something like that, or you say V dash is equal to magnitude of A1 plus magnitude of A2 magnitude of A3, something like this. Okay, or you can say modulus A1 plus modulus A2 plus modulus A3. What is modulus? You have modulus minus 3, your answer will be 3. Modulus 3, your answer will be 3. Modulus minus 5, your answer will be 5. Okay. These two symbol is called as modulus. These two symbol is called as modulus. You have to understand this, okay? If you put a negative number here or a positive number, your answer should be always positive. Your answer should be always positive. So, your A1, you are taking the modulus A1, so that is positive. Modulus A2, the answer will be positive. Modulus A3, it will be positive. Okay. So, you note these things. Okay. You have to note these things. Okay. Now, some of you may have some confusions, right? For such students, for some students, they may have some confusion. We are not clear with this. Okay. Suppose it is acceleration time graph. It is acceleration time graph. Take an example. This is an acceleration time graph. They ask you what is velocity. They ask you what is velocity from this graph. So what you have to do? You add A1 plus A2 plus A3. Okay. A1 will be positive, A2 will be negative, A3 will be also positive. It doesn't matter. Okay. You have to add considering the sign. So you get velocity. Velocity is V, right? You get velocity. This is velocity. Now if they ask you, what is the speed from this acceleration time graph? What is the speed from this acceleration time graph? You know, basically velocity is area, hence speed will be also area. But the thing is, when you take speed, you don't consider this negative sign. You have to add it as positive. You have to add this A2 as positive. Hence, we take the modulus. Modulus A1 plus modulus A2 plus modulus A3 plus etc. Okay. Now, if there are any students left who are not clear with this concept, they don't have to worry, because we will be doing problems in the next lecture. So, automatically, we will do many questions so that you will understand these things. Okay. So, see you all in the next lecture. I hope you enjoyed these concepts. You have understood all the things that we have teach you. So, see you all. Bye bye.